In this video, I'm going to talk about some examples of continuous functions. The first example I have is this one. Let's give it a name. Let's call it f of x, okay? Which is a rational function. In the numerator, I have x to the power 4 minus 2x, and the denominator x squared minus 25. Now, f of x is actually a ratio of two functions. Let's call them g of x, which is the numerator, x to the power 4 minus 2x, and maybe h of x, the denominator, x squared minus 25. Now, when you're dealing with rational functions, only thing you have to keep in mind is that the denominator never evaluates to 0. Okay, in our case, we have x squared minus 25. So the way we find out where the denominator is going to be 0 is by actually setting the denominator to 0. So we're going to take x squared minus 25 and set it equal to 0 and solve for x values. Okay, so which will tell us that, for these x values, the denominator is going to be 0. So you probably remember your difference of squares formula, x squared minus 5 squared, which is like a square minus b square, right? A square minus b square, that is equal to a plus b times a minus b. Similarly, x squared minus 25, x squared minus 5 square is going to be x plus 5. X is like your a, okay, and 5 is like your b. So x plus 5 times x minus 5, and that is equal to 0. So you have a product of two factors that gives you 0. Either the first one is 0, in that case x plus 5 is 0, that's going to give you x is equal to negative 5, okay? So if x is negative 5, the denominator is going to be 0. The other option is, what if x minus 5 is equal to 0? That implies that x is going to be positive 5. So for x equal to positive 5 and x equal to negative 5, the denominator will evaluate to 0. However, the numerator doesn't matter. Okay, it's a polynomial, it's a continuous function. Denominator is a polynomial, it's a continuous function all over the number line. You remember that any polynomial function is continuous on the entire number line. So this is both of these functions, the numerator, which is g of x, denominator, which is h of x, both are polynomials. Therefore, both of them are continuous on the entire number line, meaning negative infinity to positive infinity. However, we just need to make sure that the denominator does not evaluate to 0. In those cases, we are going to be dividing by 0. Division by 0 is undefined. Therefore, we have to avoid those circumstances. And we just found out that these two values, okay, these two values, negative 5 and positive 5, is going to give you 0. Negative 5 whole square is positive 25. 25 minus 25 is 0. Then positive 5 whole square is 25. 25 minus 25 is 0. So your domain, this function is a continuous function, f of x, but your domain is going to be from negative infinity to up to negative 5. Okay? And union, that negative 5 to positive 5, because positive 5 is also a problem, right? Because it gives you 0 in the denominator, and then from positive 5 to infinity. Now, if you were to sketch it, right, how is it going to look like? So this is your number line, 0, positive 5, and negative 5. Now, what you'd want to do, you want to highlight everything except for these 2 points, okay? So let's highlight these guys. So everything to the left, everything in the middle, and everything to the right. So this is where the function f of x is defined and it is continuous. Now let's consider a second example. This time I'm going to consider a trig function. Maybe f of x is equal to sine of x over maybe 3 plus cosine of x. Again, we know that the trig functions are continuous everywhere in its domain of definition, okay, which is the real number line. So trig functions sine x, cosine x, okay. Let me be clear. Now, when I said trig functions, I meant only sine and cosines. Their ratios may be a different issue. So only sine and cosine trig functions are continuous everywhere it is defined or in its entire domain. So if we think of it as a function, let's call it again g of x, which is going to be just sine of x, and h of x, which is going to be 3 plus cosine of x. Both g of x and h of x are continuous, right? Sine of x and h of x is 3 plus cosine of x. Now we know that the ratio of continuous functions is continuous. That's a property of continuity. So the ratio of continuous functions is continuous, which is great. However, there is only one thing, again, we have to remember that you do not have any value of x that's going to make the denominator 0. In our case, that will never happen. Why? Remember, negative 1 is less than equal to cosine of x is less than equal to positive 1. So that means cosine value is restricted between negative 1 and positive 1. The smallest value it could have is negative 1. In that case, you will have 3 minus 1, which is 2. And the largest value it could have is positive 1. So it's going to be 3 plus 1 is equal to 4. So it's going to be restricted. The denominator is going to be restricted between 2 and 4. So, of course, between 2 and 4, there is no 0. So that tells us that this function f of x as defined is continuous on the entire number line, and its domain d is equal to negative infinity to positive infinity. And again, if you want to kind of sketch it, so this is your 0 and it's going to be highlighted everywhere. Right? It keeps going this direction and keeps going in this direction. I hope that this discussion was helpful. Thank you very much.